Hi, everyone. Okay, so with today's video, this last chapter 6, I haven't mastered it yet. I'll probably do a second follow-up, but I just want the pleasure of doing this and talking through it just before the assignment. Remember that this PowerPoint is created and meant to be used with Cognitive Psychology, the second edition, EMEA edition by E. Bruce Goldstein and Joanna C. van Hoof, and published by Cengage Learning, EMEA, in 2020. Now, this is material used by UNISA students in module PYC3703. None of this is my own work. None of it is intended to be useful for cheating. It is simply collaborative learning and another chance to present the material to ourselves in a way that engages the mind. So I hope it's useful. If it is, I'm saying all of this because of the scary letters about plagiarism and cheating and so on. So I wanted to be very clear what I'm doing here. What I want out of this is like, share, and subscribe. Okay, thanks. All right, let's go. Long-term memory, structure. Long-term memory is the archive of information about past events and knowledge learning. It works closely with working memory. Storage stretches from a few moments ago to as far back as one can remember. And more recent memories are more detailed. If you think about your first toy, you probably remember it, but only vaguely. Okay? Think about your latest phone, you remember it very well. Long-term memory. Long-term memory covers a span that stretches from about 30 seconds ago to your very earliest memories, all classified as long-term memory. Shorter than those 30 seconds is short-term memory. Okay, you can distinguish between short-term and long-term memories using the serial position curve. Now, this means exactly what it says. There is a series of positions in time, okay? And there's the percentage recalled. So the first thing you hear, you are more likely to remember in the series. You hear the second thing, third thing, fourth thing, by the fifth thing, it's dropped. Kind of stays pretty low until about if you're presenting 20 things, then the first 5 things or 4 things and the last 4 things are going to be easier to remember. Now look how much higher the last things you remember are than the first things. This is the recency effect. The first things you hear, the primacy effect. Hang on, I've got to turn off the washing machine. Okay, so Murdoch created this graph of the serial position curve, right? We have the primacy effect, primacy meaning what you heard first, and the recency, what you heard most recently or learnt. Okay, why is the primacy effect higher? Because you've had time to rehearse information, so you're more likely to remember it. Okay. Now, the more you rehearse, the more you remember. And you can see that rehearsal and where it is in the series is directly correlated for the first part of the curve. Let's look at the recency effect. This is partially because the stimuli are still in the short-term memory, not in long-term memory. Okay, because as soon as you delay recalling the information for 30 seconds, there is no recency effect. So the recency effect is not actually a function in the long-term memory. It's actually simply an indication of short-term memory. Okay. Visual and auditory encoding in short and long-term memory. Semantic encoding. Wickens and co-workers. There was an experiment that showed that interference is enhanced by the meanings of words. I don't understand that. We might need to come back to that. Wickens experiment, 1976. Oh, here we go. Okay, so we've got the fruits group and the professions group. On our left, there were 4 trials, each with different fruits. In the professions, there were 3 fruit trials, 3 profession trials, and 1 fruit trial. So let's see, those are the stimuli, and this is for short-term memory. After each presentation, subjects counted backwards for 15 seconds just to make it difficult to remember, and then recalled the names of the fruits. Professions had the same job. Let's see what happened. This is semantic coding, remembering information. The fruits group, can you see the first trial is up there, round about 80 to 90% recall, and then it decreases until the last set of fruits that was presented in trial 4, it's about 20 to 30% recalled. The professions, can you see there? They went profession, 80 to 90%, profession, 30 to 40, profession, 30 to 40, and then they were asked about fruit, and they went right up and remembered about 70% of that information because they were released from proactive interference. In other words, when you're trying to remember the names of fruit and somebody else is telling you fruit words, you're going to forget what you're doing. This is short-term memory. This is why you don't want people saying numbers when you are counting, but they can usually talk to you about the weather, but not mention any numbers. Okay. Okay, in long-term memory, we're talking about semantic coding here. Semantic coding is about information. There's recognition memory. When you recognize something as familiar, you remember what it is. And semantic memory is also when you remember generalizations, you remember the general meaning, the gist, the outcome, the conclusion, the strategy, but you forget the specifics. You forget the specific details and the specific wording. Examples of coding in short-term memory. Okay, so we're looking at visual, auditory, semantic. Short-term memory in visual. Now this is something that artists spend a lot of time developing, is short-term memory skills so that they can draw what they see. So you look up, you see the shape and the angles, you look down and you reproduce it. Then you look up for the next little piece of information and reproduce it. So that's short-term visual memory. In long-term visual memory, you visualize something you saw a long time ago. Now, as you get better at art, you can actually draw things from long-term memory. And that is one of the most useful skills you can get in order to create realism in your work. It's one of the secrets towards being able to be effective in creating realistic art. Okay, auditory memory. Similar, okay, also very important for the arts. So if you can represent the sounds of letters just after hearing them, like when you learn words in a foreign language for the first time, you can reproduce it immediately after your teacher or your tutor says those words. But 5 minutes later, 1 minute later, 30 seconds later, it's gone. Okay, whereas long-term auditory memory is when you can remember what you heard many years ago or 1 minute ago, both count as long-term memory. Semantic memory, okay? If you can categorize words in a short-term memory task, you've got semantic short-term memory. If you can recall the general plot of a book or meanings or information like how to change a tire in your car, that is semantic memory. Or remembering that Rome is in Italy. Those are all examples of semantic memory. Okay. So now we come to locating memory in the brain. Now I really want to come back to these because these are fascinating human interest stories. HM is extremely famous. He was someone who had, I think it was cancer in the brain. They saved his life, but in order to do so, they had to remove his hippocampus. Remember, the hippocampus is involved in memory. He retained his short-term memory, but he was unable to transfer info into his long-term memory. So he couldn't form new long-term memories. He had all the ones he had before the surgery, but he couldn't form new ones. And this poor man, I think he must have spent his life being experimented on, or having a lot of experiments anyway. So I'm hoping to do another video so we can go into these, because these are very interesting. I'm not sure if this is going to happen though. Okay, then there's patient KF, who I haven't heard of before. Now, patient KF had an accident that damaged his or her parietal lobe. Parietal lobe, remember, it's parietal lobe up here, okay? So this person still had a long-term memory that worked, but short-term memory didn't work. And this person was actually able to form and hold new memories, although they just couldn't remember more than a, so the digit span was reduced. I don't know to what, I'm curious about that. So they could actually still learn, just more slowly and less effectively. Now we've got the example of double dissociation. This is really unfortunate. Double dissociation means that there's brain damage to two areas of the brain. Okay, well, that's what I'm understanding is right now. Correct me if I'm wrong. Okay, so one area of the brain means that one part of the function doesn't work, the other one does. Then there's damage to another area of the brain at the same time, meaning that function B doesn't work. Okay, I'm probably wrong. We will have to research that. I will do my best. Episodic and semantic memory. Do you remember we were talking about episodic buffering? Episodic buffering? To do with short-term memory in the previous chapter. That had to do with the narration of your life, which is autobiographical memory, or the story of what you did. So it's about events, episodes. Episodic memory is about mental time travel. Remember when you proposed to me. Okay? Remember when you left me. Okay, semantic memory does not involve mental time travel. It involves knowledge and facts, such as Paris is in the capital of France. Okay. So if we look at patient KC, what? I thought patient KC had a damaged parietal lobe. Okay, again, we have to come back to this. If a person, so let's assume this is another patient. No episodic memory, cannot remember what happened to them, but can remember general information. How bizarre. Can you imagine living life like that? How strange and difficult it must be. I think there's a beautiful video on YouTube about this wonderful composer and pianist, and he had that kind of damage. And the story of his wife and how she stood by him. It's probably worth looking for, and if I can find it, I'll put a link in the next video, because I'm about to do my assignment. Okay, then there was an Italian woman. She had encephalitis at 44. She had an impaired semantic memory. So she could remember everything that had happened to her and create new event memories, but she couldn't learn like uh, for her to do a course like this would be no good because she wouldn't be able to retain that information. Must have been incredibly frustrating. Okay. Okay, this is because these parts of memory are in very different parts of the brain. Here you can see the yellow is the episodic and the blue are the semantic. So totally different parts of the brain, which is a blessing in a way because then at least you've got some memory, if not other. So it's interesting how patchy the memory can be. Okay, now episodic and semantic are related because what happens is that you remember your life in episodes and then over time you gradually transfer that knowledge over to the semantic memory. For example, I know that I had a donkey when I was 6. I remember that. I remember a few moments with him, but I don't remember it like I did when I was younger. Now I just remember that I had a donkey and this is how it went, but I don't remember the actual events. Okay. Autobiographical. So you can enhance semantic memory with episodic. This is another trick for learning, is to create an association with memories that have other meanings for you. So it amps it up. Okay. Autobiographical is specific experiences and includes semantic and episodic. Like I know I had a donkey, that is semantic. And I remember giving the donkey some grass, and that is episodic. Okay. Personal semantic memory is personal history. I had a donkey. Okay. It's a fact, not an event. Okay. How time affects memories. Obviously, as time goes past, your memories decay, meaning that you forget. It's not all or nothing. The more familiar you are with information, the stronger your semantic memory. The more you can recollect, the stronger your episodic memory. Some people have amazing episodic memories, and some people have phenomenal semantic memories. Some people don't. So there's a spectrum of ability. We do semanticize remote memories and we lose the episodic details. And this is a graph showing that process over time. Now, what do we have episodic memories for? Well, it seems pretty clear. You need to remember what happened in your life so that you can plan for the future and guide future behaviors. So it's obviously important, and animals often have very good episodic memories or memories of you. This person is trouble. This is safe. This place is good. This place is no good. This is what happens after that, which I assume is episodic. Anyway, it's definitely adaptive and helps us to think about the future. Okay, now we have, remember in the beginning of chapter 5, we said that not all memory is conscious. It turns out I was right in that guess because long-term memory can be explicit, which means conscious, obvious, okay, semantic facts and episodic. Or it can be implicit, meaning it's implied, it's in the back of your mind, but it's not actually conscious, like procedural memory, how to drive a car, priming, such as racism, racial conditioning, heuristics, schemas, and conditioning, such as, this stove always gives me a shock, so I don't touch it. Okay. All right. Implicit memory. You don't consciously remember. Procedural, priming, conditioning. Okay? PPC. Skill memory. Memory for actions. You don't remember how you learned to eat with a knife and fork, but you do know how to do it. People who can't form new long-term memories can still learn new skills because skill is not the same as semantic long-term memory. Coming back to language learning, language is a skill, and it's as much a skill as it is semantic. So you don't have to learn it with consciously thinking about it. Babies don't think about language when they're learning it. They just do it and develop the skill. Priming. Okay, this changes your response to a stimulus. Repetition priming. Okay, some people have amnesia and you can still prime them. So, okay, that's also interesting. I'm hoping this is in chapter 6 so I can read up on it. Okay, here we go. Here's more info. Okay. Amnesiac patients did poorly on the recall test, and the poor recall confirms the poor explicit memory associated with amnesia, but they did well with the implicit memory test. Okay. Ooh. Okay. We'll have to look at that in the book if you want to understand it. Okay, the propaganda effect. This is priming, of which we are now. It's becoming a massive problem in society right now with adverts and propaganda and AI. Okay, classic conditioning can happen to people even if they've got amnesia. And that is that. Good luck, good luck, good luck, good luck, good luck. And see you after the assignment for whatever chapter we're doing next, and possibly to come back to this and round out a few questions around the interesting people with their brain damages who helped us so much with patiently going through hundreds of tests. Okay, bye.